long code. Oh, are we starting already? Are we starting?
Hey,
Okay.
all right, then hold on. Mhm.
All right.
Fellow Ghanaians, you're all welcome. Stephen, Sir Stephen, um, Andrew, and Gabriel, thank you for joining today. So today we are having introduction to machine learning, and Hakim was only showing us an example of what they've been working on, and then giving us more details on what it involves. So today's class is an initiation into machine learning. Then in our phase two, which is going to start maybe in the next 30 days or so, um, we'll get to practice machine learning and do stuff. So um, we want to start, but we won't keep long today. Today we will just do 30 minutes. That's the next 30 minutes that we are done. Yeah. So we are going to start now. Then we'll do some recordings. We'll put it on the YouTube channel also. Then we'll come back to have a discussion. So over to you, oh Lord.
Okay. So hi guys.
So I think you can
I think I should go back. I don't know if I should start what
so
I
you
was
can
just
now
saying.
start the real lecture. But we
Oh,
have,
okay,
as you
okay.
said,
So
we are not going to keep long. Just a
yeah,
small introduction.
more
Then
introduction is.
So you can show us how your model works again.
Come again.
I'll show how the model works again. So
Oh,
that
okay, okay. So we have this model which is part of a
so now
framework.
welcome to machine learning.
Yeah, yeah. Welcome to machine learning, and let's. We are just showing you just a sample of what the machine learning can you can do with machine learning, right? Because sometimes I think in if you go to certain places in companies, sometimes in people's personal houses, I think even just below our website, I had it where we work. Steven, there's they have this this AI market. They sell gadgets, security for AI and for security, mostly with AI embedded in it. And they have heat sensors. Some do object detection when cars are moving. So they detect the kind of cars going. Some of them too are like for security purposes, heat sensors and all those things. And how does it know that this is this? How does it predict and all those things? It all starts with this particular machine learning, the kind of models we write. So this is just to show you one example of what it can do. In this case, it's predicting objects it's seeing around. This is just general objects. It's seeing a bench, it's seeing cars, it's seeing a truck. I can't this one I can't really zoom in unless I open it in an image. So let me show you something else. This is something we just did yesterday just to try out, and this was the image. Like I was saying, this is the original image, and depending on what you are doing, in this case, you are doing object detection. You want to detect the people in particular, but anything else around that. And you can tell just from here, you see that it do this kind of boxes, some or rectangles around them. And we call in annotation, we call this bounding boxes. But they are bounding a particular object in a box. So I'm sure that's what I call bounding boxes. So the tighter I realize this one is not as tight as normally when we are labeling it as data specialist, we will make it tighter. But all that is just technical. We'll talk about this. But as you can see, it was able to drew a box around someone and say this is a person. And this one we didn't do it manually because normally we would do this and give it to the machine. The machine will train and the output. The machine should be able to predict everything like this on its own. So the machine just was able to, the model was able to just know that predicts this person as a human being due to the features that it was trained on. It was able to predict this as a handbag due to the other. You can see another handbag over here due to the number of handbags that are seen. So you can tell, okay, this can be a handbag or this should be a handbag. And as you can see, there are certain values attached to these predictions. We call these confidence levels or confidence bands. And what do they do? Um, it's basically how confident you are in answering or in solving this question. So in in giving this answer. So the model is saying it's 73% sure that this is a human being. So it's not 100% sure, but it's 70% sure that this is a human being. And it's also 37% sure that this is a bag, and it's actually a handbag, but depending on what you call a handbag. So each object, you can even see here, I predicted an umbrella. It's 35% sure, but maybe due to, because it's probably due to the obstructions, because of there are a lot of people occluded in this image, so it's not really able to see all the features, but I was still able to predict that this is a umbrella, but with a low confidence level. Yeah, and machines, honestly, machines are not smart. The models are not smart. Honestly, they are really dumb. Like, honestly, that's one thing you should go away with. That the models you are going to train they don't know anything at all. They are worse than babies. They don't even know anything at all. You have to literally tell it, do this before it does that. That is, so whatever is happening here, you have to tell it what to do. You have to train it for it to know something. Because the machines initially, they are really, really dumb. They don't know anything. They don't know what is going on. All they know is that they are just there. So you have to now train them on certain machines or certain models, certain images that would help it learn. Yeah, so that's why I call it machine learning, because you are learning. You have to help the machine learn whatever is going on. So here it did pretty well. You can see over here, it didn't really do well. One of the issues could be that the machine, the model is how do you call it? The model didn't have this kind of scenarios when it was training. Blurred images, because you can set up blurred images, so that can kind of confuse it. So depending on what you feed to the model, and to be honest, 90% of the time, the issue is not from the model, the issue is from the data. If you don't have the right data to train the model is basically, no matter how good the model is or how perfect it is, it won't be good. It won't be able to predict as much as you'd want it to predict. So no matter how good your model is, you need data. You have to train the data really well. You have to label the data. And this case, in this labeling phase, that's what we do in annotation. We do the annotations where we draw these bounding boxes for the model to learn. So in this kind of scenario where this is blurred, we would maybe look for more blurred images, and to get in case that's what the client wants, or the client is bringing this, then we train them on more blurred images. We draw the boxes, and the output of the boxes is what we would use to train the model. And this is an example of how the output looks like. This is just one example of the output. It's showing the prediction in numbers. So it's not telling you that this is a car, but it's representing it by 2 or a number. That's because we're dealing with computation, and normally everything that has to do with words it converts to numbers, because the machine or the model we are going to use, or even our machines process data faster with numbers, numerical data that we call it numerical data. So we convert everything to numerical data to be able to do the processes fast. But that doesn't mean it's everything is lost. So as you can see some numbers like 2222200. These are, in this particular model, we call it classification. We'll talk about the rest, but this particular one I'm showing you, we are classifying something we are seeing. So we are classifying this as a bench. So we know that if everything is a bench, maybe it's probably 2, depending on the encoding you are using. Or anything we are seeing as 0, that should be a car. Anything we are seeing as 7, that should be a bench. That should be a tree. So depending on the classification that is going on, it classifies it. So this is like how an output looks like, and it gives you the coordinates too of the bounding box I just told you. And so it's a box, so it should have 4 coordinates, which is the x, y, the w, and the h, the x, y, width, and height. And I don't know if I should explain. I'll explain that what the x, y, width, and height is in level 2. I don't think that is needed right now. Yeah, but basically everything we are doing here, we will need two Python libraries to work with, and these Python libraries are called Numpy and Pandas. Numpy, why Numpy? What is Numpy? So that's what I'll just briefly show you, just briefly explain, and you would know why we use Numpy and we are using Pandas. It's not going to be a long explanation, but Numpy is basically, I would say it's a universal standard for working with numerical data in Python. When working with Python, it's a universal standard. because when I work, and like I said, everything that it has to do with even words, it converts it to numerical data. And why is it fast? Why do we really use NumPy? It makes everything fast. It makes your computation and operations fast. Normally, when you're working with a real life project, you'll be working with a lot of data, a lot, thousands of data. And if each and every one of each data is just one, it's just one image, and just one image. See the number of data points and things you're having for just one image. So imagine you working with about 100,000 images. How would the machine be able to process all this? You know, we can use the normal arrays. That is what we have been doing in Python, where we have like 1, 2, 3. This code represents the some arrays. But in NumPy, when you I will show you an example. When you try to do the same thing in NumPy, the computational speed is very fast compared to the normal arrays we're using in Python. That's the list and stuff we're using in Python. So let me just show you an example. I'm importing a library called time. So from time, import time. The name of the class is called time, and the method is called time. That's why it's saying from time, import time. But don't need to know about, don't worry about this. But I just want to show you an example for you to see how it looks like. So let's see. I say so start time. Let me start time. How do I start time? Is equal to time, and I do a computation. That says please don't worry too much about the code at this point. Normal, and I say a for a in. Okay, let me give it a value over here, saying number is equal to 8. Let me say 10 raised to the power 100. This is a lot of numbers. 10 to the power 100. So I'm saying for a in a, it should for a in a in range of number. Yeah, and let me do stop time, which is equal to time. Now let me find out time. Equal to stop time minus start time. So let's print final time. The time. So this is just showing the time it took for me to print out 1 all the way to 10 raised to the power 100. I don't know what 10. I mean, let me see what's 10 raised to the power 100. Print. That value is 10 raised to the power 100. Wow. See how long it's even taking to predict. Okay, well, it is now connecting my Jupyter. So let's let it connect. When it's done, it should print. Yeah. So this is the amount. This is I don't know if I can't even pronounce this value right now. So I'm saying that in this particular code here, I'm saying print from 1. So print 0, 1, 2, 3, 4, 5, all the way to this last number over here. So it's going to print from 0 to 1 all the way to this. I don't know. I don't think I can even pronounce this. It's not millions. It's past billions. So it's going to print from 0, 1, 2, 3, all the way to this. That's what it's doing over here. It's giving me a list from 0, 1, 2, 3, all the way to this. I can't print that list. I think it would slow my machine. So let me print this, and you see the number, the time it took for the machine to print to number from 0 to this last number over here. So see when it reaches here, it is, you can see the icon over here. It is meaning it's still performing what it's supposed to do. It's still working out. It's still numbering it. I don't think this will take time. I think I should reduce it, or it would slow us down. Let me say 10 raised to the power. Oh, okay, it's working. Yeah. Let me say 10. Let me say 10 raised to the power 10. I don't want to. Yeah. Then this is okay. This should be okay for it to print. Let me see. 10 raised to the power 10. How much is that? Well, it's too much. Okay, it's not. It doesn't get printed that. This is going to take some time. Okay, it's restarting. Or it's even. I think it even restarted the kernel. So let me with 10 raised to the power 5. Just do 10 raised to the power 5. I think that'll be better. So this is the amount of time. Nah, it's too small. Okay, but let's just do this amount of time it took to what's 10 raised to the power 5. This is the number of this amount of time it took to number from 0 to it's 100,000. Yeah. So if I print normal, you can see it will be 1 0 1 2 3 4 5. See, so it's where should I? Okay, yeah. So if you see over here, it printed from 0 all the way to 100,000, and I'm still counting. So it took just about 0.0073 seconds to do that. Now let's try with Numpy. Let's do the same thing, but with Numpy arrays. You see, give me a second. Let me copy all this. Put it here. And you see why Numpy is mostly used. Import. So if you want to import Numpy, is this Numpy? Like I said, it's called numerical pi, like numerical Python. So I think that's why Numpy. So Numpy as NP because it's long. So we normally try to shorten it. And I'll change here to let's say Numpy array. And I will say this should be, and Numpy, the conversion is NP. So NP, so I'm calling Numpy dot arrange. And what does arrange does? Arrange is basically like what I wrote here. It's giving me the number from 0 all the way to where it's supposed to be. So arrange of num. So it's giving me, it's going to list from the same thing it did here, 0 all the way to 1. But let's see how fast it was able to do this. Yeah, it just came, but it didn't even take time, didn't slow down. So if you can compare these two values over here, this took 0.0073, this took 0.0010. So that's like a huge amount of time. Like a time it took a process that same data faster than the normal arrays and lists we have been using. This is called a list comprehension. I didn't think we covered it, but maybe still will cover. Maybe whilst we are doing Python, we'll cover this what list comprehension is. It's a way of writing a for loop, yeah, inside the list, which helps make everything easier. In case maybe you were trying to, like, in this my case, I was trying to write 1 to 10 100,000, but I can't write that manually in my list. I can't write 1 2 3 all the way to 100,000. That is going to be so much time. So this comprehension just helps me do that in a list. So it printed everything in a list for me without me having to manually do it myself. But in this Numpy, we don't use this. We just use np.arrange, and it has its own computation that makes it faster. So as you saw, it's very fast. So that's one reason why we use Numpy. Now, why do we use Pandas? Should we use? Why I said we are using two particular libraries today. We are using Numpy and Pandas. So the question is, why use? Excuse me, I'm coming. Why are we using Pandas as well? So Pandas is a way of virtualizing your data. I think I have this image here. I just found it. I don't know if you can see. This is the image. It's a way of visualizing this data. So you can have data. In case you have some certain amount of data in this, it has common parameters. Maybe it is name of students and name of students and their age. So the columns here, as you can see, it's a tabular form. So in the table we have columns and rows. So the rows are the horizontal, columns are the vertical. So it's what Pandas does is it automatically groups, depending on a certain format, it automatically groups this data that we want to analyze or want to predict or want to run this prediction on. It groups it in a tabular form to make it easier for you and the machine to also be able to process the data. And that Pandas is built on top of Numpy. So that means the same computational speed Numpy is giving you, Pandas is giving you. Most of the time, most of these operations such as SciPy and math. No, I don't think math does that, but SciPy and other data science heavy libraries, they are all built on top of Numpy. Even the machine learning algorithms will be using, such as like the machine learning frameworks and libraries, such as what do you call it? PyTorch and TensorFlow, that's for deep learning. All that are built on top of Numpy. That is how good Numpy is and how effective it is. So I think we should have some background on Numpy on your free time, and you can just go through it. And this is so with groups, that's data of interest. So you can have this row here. The first row will be the names of the titles of the table. So here can be age, here can be name, here can be maybe grade. Then you have each of them will have grade, name for each. So each column will have, if this is name, it will give you all the names of the people, and if this is age, to correspond with all the ages of the people over here. And I'll show you an example very soon. So I'll just show you how the table is in how Pandas is. It helps you structure your data properly. So let me just copy this. Let me copy this. You want it's okay not to understand what is happening right now with what I'm copying, but I just wanted to understand what is going on in Pandas. So in order to import Pandas, we just say import Pandas. That's how it's spelled. And normally the conversion is as PD. So as you can even see here, they already did PD over here. That's the normal convention, but it makes everything shorter. And when you are running this, let me run this. So this is the data. So this is the name of the person. So this is the name. And you are putting this in a dictionary. I think we did dictionaries, we did lists, we did sets. So this is a dictionary. This is another way of having data. Most of the time when you're working with machine learning or models, most of the time you'll be seeing things in JSON in dictionaries more than lists. But you'll be seeing lists and stuff inside those dictionaries. So as you can see here, I don't know if Steven went to send you through, but let me just give you a quick overview. A dictionary is, let me just do this. A dictionary is something that is it's also like a list or a set. They all have certain features, and a dictionary is something that really helps you. It has something we call key and value, key value pair. So in a dictionary, unlike a list where you would add 1, 2, 3, and I have to look for the index of 0, which is 1. In a list, maybe the list is more broad and more flexible. If maybe I want to have maybe names of people, like as you can see over here, age. Let me use age. So I can say maybe first, maybe I want to see someone's name and the person's age, right? I can say Sammy over here, and his age is and his age of Sammy. Oh, let me do it again. Sammy over here, and his age is 5, right? We can have another one called, let me use Mr. Ivan. Ivan. And the age is, I'm guessing Mr. Ivan's age, or please, I'm not saying this is Mr. Ivan's age, 28 or 28. And we can have Steven, which is 15. So, hello, wait, hold on. Am I being heard? I can't see. Yeah. Okay. So, something like this is how we write dictionaries. And as you can see, it's denoted by a colon. So, this is the key. The key is Sami, and the value that Sami is bringing is 5. That's his age in this case. So, I can say, let me put this in let me say name age. Let me put this in a variable, and I can say, okay, I want the age of Sammy. It's of Sammy. And if I print that, I'll get 5. See, so I didn't have to. Normally, if we were doing this in a list, I would have 2 lists. I should have 2 lists, and I will have to do a loop, and say, okay, I attach this 2 to this, attach this to this end or something. But or if I want to call it, I have to work with those 2 lists. But in this case, I'm working with everything in just one dictionary. So dictionaries are really good and very helpful when you are working with data. I think we would also hit more on that when we are training when we are doing Python. But basically, that's what is happening. So this is the key value. That's the name over here, and here we have multiple names. So they were kept in a list. So you can mix a dictionary with a list. It's normal. You can mix it with other stuff too. It's normal. So here we have brand and other names. We have age and we have sex. So let's now, in it being in this format, it's really hard. Normally, this is the format you just see it in. and it's going to be very hard to work with something like this because you can't. It's going to be hard. You have to now know, okay, this is brand and this is his age and this is male. You have to like be going all over and over again, and that's going to be stressful for you. But with pandas, if I just do if I put it in a pandas data frame and I do a df, let me just do a df for you to see what's going on. I would explain the code. Yeah, you can see that it's automatically structured everything in the table for you. So we have your indexes. This is what we call indexes mostly. To index, to know that this is the first index, this is the second index, this is the third index, like the way we do in list. We have the names. As you can see, the name is brand Mr. Owens, Mr. Owen Harris. And I think the same thing. So these are the names for everyone. These are their corresponding ages. As you can see, 22 is for this first one, 35 is for the second one, 58 is for this third one. Same thing over here. And their sex, male, male, female. So as you can see, Harris is a male, Henry is a male, and Elizabeth is a female. So it helps us structure our data, and we can perform a lot of computation with this. And normally, you won't. This is a data we just created. Normally, you don't create data like this. You have data in the various formats, such as CSV. I think I should have it. Because we are not doing anything into details, we are not really going to read anything for now. But I want to just show you how some of the data looks like. This should be one of it. Excuse me. Current output. No. Yeah, found one. This is a CSV, comma separated. I've gotten the last thing. So you can see data like this. This one mostly when you see data in this format and it's in a file, it will be called JSON. It's a JSON file. So this is a JSON file. Normally, if it's in a file, then right now we just call it dictionaries, but if we save this one, or if you are saving this right now, we save it in something called a JSON because that is how JSON format looks like. But I don't want to talk about all these formats and everything. Just know that we have formats that can be are used to store data, and when we put it in that format, pandas or some other visual that other structured libraries can read that format. So in this case, I think this is something that would work where I was planning on us working on, but we'll work on it in the next level 2. So this is a CSV. This is also one other format of holding data, and this CSV has indexes. It's about a retail shop. As you can see, it's online retail. So it's a retail shop where you can see invoice numbers, stock code, description, invoice data, the unit price, and custom data in the country. So this is an online shop where maybe someone was purchasing something. So this is the invoice number for the person. This is the stock code. This is the description. That is the white hanging hats. Can I zoom this? I don't know if it's possible. Steven, how do you zoom in VS Code? Okay, I found it in VS Code. So it's a white hanging hat lights, tea light holder. That is the quantity. That is the description. The quantity is 6. Maybe the person bought 6. And invoice dates. This is the invoice dates. This is the unit price. Sorry, the unit price is 2.55. It can be in dollars, probably. And this is the customer ID and the country the person bought it from. And as you can see, the index. So in this case, this is one of the ways that the formats the data can be in, and we can read it in pandas. And to structure this in a tabular form for us, let me just try and do that. I should be able to do. I should just do that for you to see. So you see how it structures it. Give me a second. Yeah, let me just copy this and paste it over here. I think that would make everything easier. Oh, what happened? Yeah, it didn't work. Give me a second. Let me do it again. Okay, I think I need to hold on. I think I need to extract it first. I didn't extract it from the zip file. Extract. Yeah. Keep this. Okay. Now, let me show you how it looks like. So, like I said, when you're posting Pandas, when you're working in Pandas, you don't need to focus more on the syntax right now because it's not. I'm not going to teach you. I'm not teaching you the syntax, but I want to see what is going on. But it's just import Pandas as PD. And in this case, I want to read this data frame. It's still loading, so but I want to read this data frame inside Pandas. So Pandas automatically know that this is a CSV. Like I have to tell it, but it will automatically structure the data for me. How will it do that? So normally some of the conventions we do is DF. DF means data frame. So I'm putting this whole thing in a data frame. In a data frame, like I said, is a structure that we are structuring the way we structure the data. That is what the data frame is. And we have dimensions of that too. I think that one would, I don't want to go too deep into that. So we'll talk about the dimensions later. So a DF is equal to, now I want to read right now. This case, it was just a normal data and I was just calling structuring it. But I want to read this data because it's a CSV file. It's a file that is just there. So I want to read this data into Pandas. So the syntax for it is PD. Sorry. PD.read underscore CSV. Depending on what you're working on. If you're working with JSON, PD.read JSON. PD.read I think we have XML. Yeah, look at it as you can see them over here. Yeah, XML, we have JSON, we have Excel, we have HTML, we have a lot of SQL, we have a lot of data types that we can read with Pandas. That's the beauty of Pandas. So in this case, we're reading a CSV. So CSV, and I have to pass in this name, but it's still loading. It's almost done. Whilst it's loading, what should I talk about whilst it's loading? Give me a second. Yeah. So let me go back to Numpy for a bit. You know, Numpy helps with our operations very fast. And how does it do that? There are lots of ways Numpy can help us with what we are working with. And it's everything that happens in Numpy also cuts across Pandas. That's a beautiful thing. So you don't have to like do Numpy. You can do some certain Numpy functions, but it's not using Pandas in particular. Whatever you're calling also triggers these Numpy features. But let me just show you what Numpy does. I think I had some notebook talking about it. I don't know if I have it over here. Yeah. So there are 5 main things that NumPy is really good at. That is, one is multi-dimensions. So what's multi-dimensions? It means we can have multiple dimensions in NumPy. We have something called 1 dimension, 2 dimensions, and typically this is like a 1-dimensional array. If I do this, do np.array. This is how to convert a normal array, in this case, this list, into an array in NumPy. Because so in the normal, if you have a normal list, you want to convert it to a NumPy array, you just do np.array. If you wanted to use that same computational speed and everything. And I have 1, 2, 3. If I print np.shape, yeah, np.shape. Sorry, this won't work. This won't work. Let me give it this thing, a number. So number, and I say number.shape. It gives me 3. No, let me do end them. Yeah, number that. I want to show the dimensions. And it also means 1 dimension. That means just 1 array, 1-dimensional array. If I put this into if I find out that one thing, I think one rule of thumb I used to put in mind how the number of dimension of arrays it is the curly braces. So now using 2 curly braces, right? And in these 2 curly braces, we can have another array with 2, 4, 8, 4, 5, 6. And if I print it will give me 2 dimensions. So this is 2-dimensional array. So you can have multiple dimensions in NumPy, but typically our world is just 3 dimensions. We can have up to 4 or 5 dimensions in numerical format. But and these dimensions help us to work with data properly. I don't want to really talk about it. It's too much. But how many of us know what a matrix is in maths? Remember, we used to have something like a matrix. I don't know if I print this, if it will work. If you can see how the matrix format is. Yeah, you can remember that time we used to have a matrix, like we used to have something we called matrix in maths, where it will be, you have like one big we have two big one big open bracket and small bracket, and there are numbers there. You are supposed to perform certain computations. So most of the time, uh, 2D data is like that. So even if I add another, not another curly braces, but another list over here, you realize that it looks more like a matrix form. One dimension is just one straight form, and 3 dimensions mostly or higher, we call them tensors. That's why I said this particular one, the image was a tensor, because it has, I won't go there, but it has certain dimensions that it's more than 3 dimensions in the images. Okay, this is almost done. And one thing about NumPy is you can add like 2 NumPy arrays together so easily. Let me show you what I mean before I move to the Pandas section again. This is let's see. Let me do this. So 4, 5, and 6. Let's say number 2, right? I can do NP. I can do oh, this way. I forgot it. Num plus num2. Yeah. I'm getting an error. Oh yeah. You realize that I was able to add this. I didn't have to call the first one and second one to add it. It gave me 5. I called 2 and 7, 2 plus 7, which gave me 2 plus 5, they gave me 7. 6 plus 3, which gave me 9. If I was supposed to do the same thing in a normal array that we'd have, if I say A is equal to 1, this is just a normal list. In mostly if you arrays, it probably means a list in Python. So B2 is, let's say 5, 6, 7, 8, right? If let's just watch what happens if I do A plus B. See what happened? It didn't add up. It rather attached it. So it was 1, 2, 3, 4, and became 5, 6, 7, 8. You can't perform addition on a list like between 2 lists, unlike NumPy. NumPy gives you that that particular ability to do that, and that's one way of making NumPy very useful. NumPy can do it can generate a lot of things for you, but I think we'll hit more on that when we are talking about NumPy. And we can also do the same thing in NumPy with the concatenating, with something we call concatenation. So we have an np.concatenate, which will just do this simple thing for you. You just passing A and B, just like we did, without adding any plus. It will do it for you. So NumPy is really flexible when you are working with numerical data. You can do a lot of things. You can do a lot of hard, difficult computation, agent values. When you're computing some certain agent values and other values, NumPy can help you do all that. But like I said, Pandas is a bit on top of NumPy. So whatever we are doing in Pandas is the same thing that we are doing in NumPy, but better. Like, I mean, for not better, but for structured data. So here I have loaded the data. That is the online CV. Let me copy the path and let me read it. So you see how it looks like. Let me see how it looks like. Let me read this. And if I print, we have something called df.head. If I say df.head, I'll explain that in a bit. Let's print. Yeah, it's a lot of data. So as you see, it just printed only 5 rows. So when anytime I do df.head, it means print just the top 5 or print just the top. But I can't print a lot. It's a lot of data. It's a lot of data. So it might take some time. But that doesn't mean I can't print a lot. I can do df.head print print 100. If I put something in this function over here, 100, it won't print just 5 to make the first 100. So if I just do this to print the first 100 data frames, but as you can see, it won't show because it's a lot. So it gives you this ellipsis, here, to tell you that it's from 0 to 99. And as you can see, you have 100 rows over here. And you can perform a lot of things with this, a lot of things. I can analyze my data in case maybe I want to know the number of data. In case I want to know my information, I can do df.info. I think I think you have to call it df.info. You would see that, okay, so the index column, you see columns, you see numbers, you see the data types. So you can see, okay, in the index column has integers. The invoice are objects. The stock 2 are objects, because I think they are mixed with numerical data and how do you call it? strings too as well. Customer ID is float. So in case maybe stock code is supposed to be a float, this describe or this info method has given you an information that this data type is it's an object. So you can now convert this into a float depending on what you are doing. So it's to analyze the data or that whole bunch of data without you having to go through that hundreds and thousands of data. I think it was how many rows of data? Let me check. It was about it is about 541,000 rows of data. You can't go through that to tell if each and every one or is an object. We can also do something like let me just go down. If I say df now, you know the df is the data that we have read. You can do something like df dot describe, and it will describe your data for you. So it's saying that okay, these are the invoice, like it's breaking it in terms of each column. So it's giving you the kind of this is quite a little bit. I don't want to explain to you. I think you may get confused with this, but this is basically describing the data. Hold on, give me a second. Yeah. Yes, this is how it's supposed to be. So this is giving you the count, the total count of that's the total number of rows index has, the total number of rows quantity has, unit price has. So you can see if your data is continuous or not. So sometimes so in this case, the customer ID is just 400. That means they are 406,000. That means there are 406,000 unique ones, unique IDs, unique customer IDs. That means maybe in each, like as you, I don't know if you saw over here, no, not this. Yeah, you saw over here. There's some customers have the same kind of IDs over here. So as you can see, some customers have the same customer ID because they are the ones who purchase the same products over here. So it's understandable that you, in terms of unique values, when I say unique values, the ones that are not duplicated, because as you can see, these ones are duplicated over here. But I want to know how many customers in particular bought stuff, not number of things they bought, but how many customers in particular. So you know, okay, I have about 406,000 customers that bought stuff out of the 500 and something thousand rows we had. This is the mean. The mean, I think you know what the mean is. We're looking for a mean value, like the average. So the average value. So here you're tracking an average. You can use it for some computational stuff. Here is the standard deviation. Is the minimum value and the maximum. This is a 25 percentage. We'll talk about all this probably later. I don't want to go too deep in this and confuse everyone because I'm just skipping through everything. So this won't be much, but this is just to describe and help you know what data you're working with. And let's say let me print another. Let me just print the df.head again. Okay. So now let's say I want to see the number of countries. Did they have countries? No have countries. So I want to know the number of countries that that's currently purchasing my stuff, so that I'll focus there. I want to focus there more. I can have so basically count a lot of things in it. If anybody has a suggestion, okay, you want, if you see this data right now and you think you have anything you want us to find out, let me know so that I'll just try and write the code. Right now, we're not really looking at the code at this section, but we just want to look at what it can do. Yeah, so if you think maybe looking at it, because in this case like this, when I just saw this, I spotted something when I just saw this, that we have a unique price. So we have unit price, and in the unit price right now, we don't have total price because as you realize, we have quantity is 6, and the price of one is 2.55. I may want to have another column here that would give me the total price of quantity and unit price. I can do that. I can have another column called total price that will give me that. Let me do that. Okay, I was talking about the unique first, so let me just do the unique one and we'll just move on to that. So I can say df.country, and yes, I can also call individual columns. And in data frames, if this whole thing is called a data frame, but a single column is called a series, and a series is like a numpy. So in series, it's like a numpy array, basically one numpy array. It's one numpy array of implicit array. So I'm calling country. If I call country, I can see all the countries. over here, but maybe I want only the unique countries. How many? I can just okay countries dot unique over here. Hey, I suppose the unique wrong. Unique over here. And you see, these are the unique, these are the because as you can see, they are duplicates. You can see United Kingdom just in the first five. And there's only one person who bought it. But once the unique countries, each and every one bought it from. And I can tell by here, I can tell here that okay, these are all the unique countries that these are the countries that I'm mostly getting my sales from. I can have a pivot table. That one is more a little bit advanced. I won't do that now. But I have a pivot table like you do in Excel where you can see how many people are from United Kingdom, how many people are from France, how many people are from Australia. You can categorize them in that sense. Okay, know that okay, majority of my customers are coming from United Kingdom. So I am going to push more of my products in United Kingdoms or push or open a branch there to get more people. So this helps in case you're having a sense of like a business or you are working for another company and you want to expand. Pandas is one of the main programming language, one of the main libraries to use when you are working with data. So as you can see here, I saw the length. I can decide to use a custom Python function called length to find the length of this unique data. That means you have 38 countries that are purchasing from my store. So you can perform Python computations the same way with the libraries easily without you having to do any learning additional stuff. The only additional stuff you need to learn is the library commands. So let's just move to one last thing. That is the how to add how to create another column to have a total price. Because imagine if you're a teller or be a working you're a teller in that company and now they're asking for this kind of information. Or maybe you have to, at the end of the day, you have to give me the total price of if this is 6 and this one unit price. I want to know the number of people who purchase stuff in a day. I want to be stressful for him to now have to calculate this and this separately for each and every row, then add everything up. That will just be messed. That will mess up. That will just be that is prone to errors because I mean it's human calculations and we may tend to make certain errors. But in this case, I can create another data frame. And increasing the data frame is very simple. All you have to do is just write the name of the data frame. So if I say total number, total price, that is I've basically created a data frame because I am calling this in the DF section. If I'm talking too fast, let me know. I know I tend to talk fast. And what I can say is okay, so total frame, total price, which is the new column I'm coming to create, is equal to the F, which is the data frame of quantity, right? So as we know here over here, we can add stuff from list to list between two arrays easily without having to write a loop. Like if you watch over here, we couldn't do that over here. You just appended it, just added it to the list. But this case, actually did the computation. So this particular thing here is come to what we are coming to work on this particular performance over here. Because this is a list. This, as you can see here, if you print only this is just a list. If you print this alone, it's also a list. So just a group of lists which has been structured in a tabular form to help us perform what we want to perform. So let's say I want to add the quantity lists in this case. Let me just say list to just give you what what I'm talking about. But normally I'll just say a column. So the quantity column, it is a word. So I'm have to put this in a string format. So we can see we are using string formatting over here, and I'm adding it, and I'm doing a multiplication rather. Yes, yeah, I'm multiplying because it is quantity times the unit price per one. So if it's six, so if one quantity is 2.55, and I'm multiplying this by the number of quantities the person is getting, so multiplied by the f of what is it called, unit price, right? Unit price. And if I am supposed to print the f right now, but head, something marvelous will happen. You can see that we've had total price over here. We've created another column called total price, which is the total price of this quantity and this unit price over here. And we are getting 30. So instead of the teller to now have to do this individually for n number of, if I say n number, I mean, I don't know how many customers that came that day, if it was hundreds or 5,000 people. That's just going to be so stressful for the person after each day to do this. You can just do this total price for him. And all he has to do is just calculate it. But even in this one, we can even do a summation. We can do the sum function and other functions with it. So basically, if what I want you to take home, what I want you to understand in this particular um, two libraries we've spoken about is that NumPy helps you to perform operations way faster than normal Python list or normal Python arrays. As we can see over here, we just did a normal plus and it just automatically did all this for us without us having to write a loop, because it would have actually written a loop. And to or still remember, if I'm wrong, let me know. But I know here would have written a loop. So now say, okay, pick this first one, pick the second one over here. But that's going to be for A for I in A, and for let's say S in B. Uh, what I'll do is print I plus S. And if I print this, you see 6. Oh, I think I made a mistake somewhere, but basically you see we are doing 6. Oh, yeah, it prints the first. I made a mistake somewhere, sorry. Yeah, I didn't do the for loop well. But basically, I was putting a loop for you to do this print. But I think there's another way we can do this, but it would make it much more stressful when we are working with this. But for NumPy, it was really fast. So NumPy helps us to perform operations, numerical operations, because everything we are doing in machine learning will be converted to numerical data. And that numerical data, we need a faster way to process it. NumPy is the best, currently, I know, is the best library to perform all that numerical stuff. The numerical data, it performs it faster, as we could see over here at the time. The time was way less compared to it you running this on a we're using normal array, normal list over here. And what Pandas does is Pandas is built on top of NumPy, but Pandas' purpose is to help you with analyzing data. And how does it help you analyze data? It structures the data for you, and it looks at, depending on the kind of structure you're using, whether it's a CSV, there's JSON, an XML file. You have different data types of files, and we'll go through that in level 2. Depending on that, it will categorize all the fields of interest into a tabular form, into a particular column for you. So as you can see, this name had all this as a field of interest, and it gave you that. And the same thing as we saw over here, we had a field of interest that is index. We had field of interest that was invoice. All these were field of interest, and they're aligned. They're all corresponding. So it's not like you are getting this particular. You're not getting white meal lanterns price for white hanging hat tea light holder price, because it's helping you structure the data properly. And when it helps you structure that data, you can perform analysis, different types of analysis on it, which helps you answer certain questions you want to answer. So in this case, where I wanted to have, my problem was to add a total price to this, because I realized that this would be stressful if I'm always having to calculate this, like, so I decided to have a column where I'll just automatically get a total price after somebody buys it with the quantity and the unit price. We can do more in case maybe we are trying to expand and we want to know which countries to expand or which countries to advertise more of our products to. We can do more computation to know, okay, which country am I getting more products from, or which country am I getting more sales from. And I can able to tell, I'm able to tell that country, and I'm able to see. I can even have a hierarchy. So, okay, so United Kingdoms is number 1, number 2 is USA, number 3 is Ghana, number 2 is Nigeria. Then with that information, I can now know which, and even sometimes some of them may have regions, so you can even break it down to which region are you getting more sales from, in case you want to open a particular shop there. Then okay, if I want to open a shop here, and maybe in the United States, in the United Kingdom, maybe East London or something, or it's a particular place that I can open a shop, because that is where majority of my data, or the majority of my clients are getting majority of my clients are buying from. So majority of people buying are from that particular location. So in this case, you're using data to back up what you are doing. You won't just guess and say, oh, let me just open a shop here, let me just open a shop here, with the hope of you trying to get somebody to buy from you. You are using data that you've gotten from your past sales to tell what kind of moves to do next. So in data sales, in data analysis and data science, in even data science, you use this data to predict. Maybe sometimes in this case you have dates over here. So I can even break this down to dates and know and have like a graph or like a visual representation of how much products were sold in certain years. And I can even use that to predict with data science or machine learning to predict next year, maybe in 2014 or this year that we are, the rough estimate or how much we are expected to get, given the data we have previously and the number of how do you call it, income we've gotten yearly. I can also predict, okay, with the income we've gotten yearly, we are likely to get this amount of income uh, given 2014, given by December 2024. And if you think you want to increase that amount, then you start, okay, doing certain analysis on your data to see how to best get more products to be sold. So this is a very good library to help you and answer a lot of your questions that you need to answer when it comes to data analysis or retail or anything that has to do with analyzing data and predicting data. Pandas, I recommend Pandas to use if I in Python. I think everywhere, mostly Python is Pandas what you'll be using. So basically, that's the two things we'll be using aside the machine learning frameworks and machine learning libraries we'll be using. These are the two things we'll be using heavily if we have to in order to work with data. Did I made sense? I think I've passed the 30 minutes, but in terms of concepts, do we understand the concept of what we did? Can I get a thumbs up if we understood the concept?
Yes, please.
Oh, okay. Yeah. So just don't worry about the code for now. Don't worry about the code for now. This is just to help you understand what we can use these two things for. Yeah. So if you are even if you are doing statistics, that is one thing you can do. You can use Numpy for your statistics easily. If you are doing anything, you can use these libraries to help you out. Yeah. So I think, yeah, Stephen, I am done with just the intro to it. I won't talk about the others. I won't talk about scaling and stuff because I would need to perform certain computation with the data I have in order to to talk about the machine learning bits, and that will take some time. And so right now we'll just pause here for you to just sync this NumPy and Pandas in to just understand what is going on over here. Yeah, so Stephen, over to you. Hello, Stephen.
Yeah.
So I am just done with a basic introduction of the power of NumPy and Pandas.
Yeah, so Pastor Ivan, I think we can stop here then in level two go into the machine learning bit.
Exactly. All right. Thank you very much, Hakeem and Steve. It's been a very interesting moment for us. And